Hello everyone. So today we will be starting arguably the most important topic or concept in programming, which is conditional statements or branching paths or stuff like that. But to get there, we have to go over some fundamentals. And so what those fundamentals are Boolean types, Boolean type data. And what that is basically just logical statements that we worked on previously when we covered logic gates and circuits and truth tables. So all programming languages and all computers are basically built on these same systems of logic that things like math are based on. So to begin with, we learned back when we covered truth tables that, we have things called statements. And statements can either be true or false. And it's the same way with computers. You can have a statement in a computer that's either true or false. Unless we get quantum computing to work, then you can exist in the, what do they call it, a superposition of both or whatever. But we'll worry about that later. Right now, let's just work with some basic facts. Like, let's say, I don't know, like I want to print out, and I'm wondering, is 5 greater than 2? Or I mean, yeah, 2. And I let's say I'm wondering if this is true or not. So I print out this kind of question, is 5 greater than 2? And I run it, and my output is true. Interesting. Well, then let's say I'm wondering if like -1 is greater than 2. I don't know that, and I want to find out. So now I run my program, and it is false. Now, like, obviously this is a very basic example, but these values that we're getting, they're Boolean values. And if we print out like type, and we look up the type, like when we put, a true in there. Oh, I keep forgetting this isn't the shell. We have to print it. And what we get is it's the class is bool or Boolean. And the same should be true if we just do this. So even the statement 3 is greater than 5 is a type of Boolean, because that's the value that produces a Boolean value. And there's only 2 Boolean values, true and false. So, alright, what can we go from there? Well, in when we covered truth tables, we covered negations, which is basically like not, right? So I could come up with like a variable, or it's equal to like not true. I don't know. Sure. And if I print out the value, or print out variable, not true produces false as my output. And if I change it from not true to not false, and now I run my program, it produces the value of true. So it's the same way. The not value is still producing us the logical opposite. So if I say that variable is 5 is greater than 3, but not that. Not 5 is greater than 3. Well, we know 5 is greater than 3 produces true as an answer. But again, when we run it with the not, it produces a false. So it negates the truth value of this statement as well. And we can even like get rid of the variable part and just put like not false, right? Run it and we get true in the print statement. So these are like data types that we can actually just throw in just like we would a number or a string, a floating type, an integer. Boolean values all work the same way. As long as what you're doing can produce an answer of true or false, it will print out that value. So if we can remember those truth tables we did, we also had conjunctions and disjunctions, like and or. So if I want to just, if I wanted to cheat on those truth tables and like, all right, I want to figure out, literally we could say, like, they always went like P is true and Q is equal to false, whatever, we can set them equal to whatever we want. We can say, all right, not P, right, is false and not Q would be true, blah, blah, blah. But we could also say P and Q. And we can find out what that would be equal to. Well, that's false. Because in an and, in a conjunction statement, both values would have to be true in order for the entire thing to be true. So only if I set Q is equal to true does it produce a value of true. Now, we can even get like, I don't know where I'm going with this. Let's just try false now. False, not false, right? Set it back to false. And now we do or. We can use or. P or Q is true because only one of them has to be true. It doesn't matter that Q is false because P is true. But if they were both false, then we would get that output of false. So, it's also commutative. We could say Q or P and we would get the same thing. So it really just works in the exact same manner as the truth tables. All those truth tables that we made produce the same things under Python or any programming language. And in the next video, we'll see some more specific examples of different types of statements we can make.